Vladimir Oselsky is going to be talking about a crash course on better SQL development. So take it away, Vladimir.
Hi. Well, thanks so much for inviting me and having me here. So, my name is Vladimir Oselsky. At least that's how people pronounce it in America. Back home, it would be something like Vladimir Ilyich Oselsky, which probably nobody can even understand. Currently, senior software developer at the small software company. And yes, I was born and raised in Siberia, since a few people were asking about it. And it does get cold there, but few people don't realize it can get very hot. One of the places I lived, it used to get above 100 degrees, high altitude mountains in the winter, minus 60, summer over 100. Have a bachelor degree in software engineering technology, so I know some .NET, and somehow I got into SQL. All right, enough about me. Let's jump into the agenda. So, road to better SQL development. How do you become a better SQL developer? And that's something I had to work through a few years ago, trying to understand the platform, because I came out of school with a bachelor degree in programming, but I still didn't understand SQL Server. I might have wrote a few queries, but that wasn't enough to actually have a job. Then I started learning about all the different tools, and then I started learning from other people on my team members. Most of them were senior Oracle people that were in the business for almost 30 years, and they could write SQL with their eyes closed. One phrase that I learned not that long ago, and I don't know who has it copyrighted, so apologies. It depends. I learned that in SQL Server you can't always apply the same solution to all your problems, and that was one of my initial problems that I was doing myself. I was trying to use the same approach in all the different scenarios. So then we're going to jump into T-SQL code, and we're also going to talk about this amazing command. And let me see, is my Zoom it not working? Let me start my Zoom it. Doesn't start automatically.
I thought for sure you were going to show truncate table.
No. All right. Okay. This one actually belongs to Brent Ozar, but I think I'm in a better position to say it. It's DBCCCP, because in Soviet Union database Shokio consistency.
I love it. I love it.
Well, that's enough with fun and games. So when it comes to T-SQL coding, like I said, there's so many different ways to solve a problem. Like sometimes you need to use a CTE. Sometimes you use derived tables, subqueries, sometimes table variables, temp tables, but you can't always apply it to the same scenario. And then when it comes to store procedure design, there are so many different ways people write store procedures, getting the same results, yet some of them are faster than others. When it comes to cursors, like I said, one of my first jobs was working with Oracle people, and they loved cursors. I probably wrote a cursor every day on the job. And then I came to SQL Server, and I was told never to use a cursor. I wasn't explained why. I was just told not to use a cursor. So we'll look a little bit into it, why cursor is not a curse. Talk about a little bit about error handling, execution plans, and some tools. So let's go to the next slide. And when it comes to understanding the platform, back when I first started with SQL Server 2008 R2 was just coming out, and they were adding all the geometry data types, adding user-defined table types, CLR, and other functionality. I wanted to learn all about it. And then I realized that I don't have time to learn everything there is about SQL Server. I found a small niche that I can focus on and get better instead of trying to learn everything. But with all the different versions of SQL Server available, you need to understand what's different between them and what each version can do better. Because sometimes, well, one of the things we'll talk about, for example, raise, roar versus throw. And in SQL Server, throw became available in SQL Server 2012, if I'm not mistaken. Trying to work in SQL Server 2008 R2 or prior can use that. So have to change the code and have to change how I'm handling store procedures. And then we'll talk about tools, because when I was working with Oracle, there was pretty much the only one tool, Toad. Everybody worked with Toad, and few people used the SQL Developer. When it came to SQL Server, everybody's using SSMS. And then finally, Microsoft 2 years ago announced SSDT. So now there's more integration with Visual Studio, and I'm actually going to be doing all the demos in the new SSMS versions 14, I believe it is now, which looks even more like a Visual Studio. And then there's also this little program called LinkPad. I'll demonstrate why I'm actually like using it. When it comes to Planet SQL tuning, we have to look at execution plan. I know there are some people that are able to do the query tuning strictly by looking at statistics and execution times, but I'm a visual person. I like to see what I'm working on. And by seeing that visual plan in SSMS, it just doesn't work. And I'll show how much better it is in the Plan Explorer. And this is not a presentation trying to sell Plan Explorer, because believe me, I can't sell it. It's free. And I'm not a spokesperson for Sentry One, and there's just won't be enough time to even cover Plan Explorer, even the smallest bit. We're just going to look at it briefly. So now let's just jump straight into demo. Slides are okay, but demos is where it is. Can you guys see my screen all right? All right. So CTEs, if I'm not mistaken, they were introduced in SQL Server 2005 or so. And one of the first ways I started using them was trying to combine queries. So instead of writing subqueries and having this long mess that it's hard to read and understand, I would just take that code and write it as a CTE, because now I define it. I know what I'm selecting, what I'm working with. I can define multiple things, and it's all pretty. It's everything has a place, and once I go to join it to it, it's very simple. There's no extra code to look at. Well, so I started using CTEs everywhere. Until I went to SQL Saturdays and I heard that CTEs could be bad. So why can CTEs be bad? So let's look at CTE. Code runs fine. Everything is good. We'll look at the execution plan. And right away, we see a problem with the execution plan in SSMS. There's just not enough real estate to look at everything that you're seeing. And most of the time, you're not going to be looking at a simple plan like this, where there's only one query. When you're debugging store procedures, you're going to be looking at maybe 100 different queries. And you have the scroll bar, and you're constantly trying to find that one thing that you want to work on. So CTEs, why can they be bad? Well, one thing I didn't know, CTEs underneath the hood are actually treated as views in SQL Server. So SQL Server will create a view and then select from it. So one of the problems that exists with the views, if you nest them deep enough, SQL Server is going to lose all statistics into objects that you're selecting from. So in that sense, you will only be able to, when you look at the estimated row count, you will only see one row coming back from that CTE. So if you nest them like you do a view, you're gonna screw up the execution plan, and you won't be able to, and you'll get a bad execution plan because SQL Server is estimating one row versus how many actually coming from that. So what do you do if you need to nest it? Well, you write a subquery, because no matter how far you nested subquery, SQL Server is going to unwrap it for you before executing it. So there still be statistics associated with it. So temp table, we'll show that in Plan Explorer. Temp tables. I love temp tables because one of the easiest things I found, I'll just select whatever I want, and then I'll just throw in a temp table. Because once in a while, I'm just a lazy programmer who doesn't want to spend the time trying to figure out how to create the table, which column it is going to be. So I'm just going to throw a select into statement, and the SQL Server is going to create all the columns for me. And then I'm going to select from it. So let's execute it. Oop. I'm forgetting my execution plan. So if we look at the execution plan, and we find one of a select statement from the temp table, we'll see that estimated row count actually corresponds to the actual row count. So there's more things you can do with the temp table than you can with table variables. Because with the temp table, you can actually create indexes on it. You can have primary keys. You can have non-clustered indexes. Whereas a table variable would only have you can have a primary key on a table variable. But there's something else that comes with the table variables. So now Plan Explorer. So, do you want to do that? So I'll run the same command, and instead of using temp tables, I'm running to table variables and doing the same select. So query almost identical, but if we look at the execution plan, query is very different. Looking at select from a table variable, we have estimated row count of 1. So then being a smart programmer, I decided, well, I'll just use table variables for very small data sets, and then use temp tables for large data sets. Well, going back to SQL Saturdays, I learned there's actually a way to enable table variables to be a little smarter. And I don't remember exactly who was talking about it, but there's a trace flag 2453, and it produces something interesting. So exactly same query running with the different trace flag, we have a different execution plan, which if we go back to temp table, it looks very much like the execution plan that came from a temp table. And if we look at what's going on here, we'll actually find that estimated row count and actual row count are identical, even though just before selecting from that same table variable, we're only getting one estimated row versus the whole, everything. So do your research. Don't go to your production system and start turning on trace flags. This is not what this session is about. This session is about talking different possibilities that you have to approach the problem. So this trace flag will enable some statistics in table variables, and you'll be able to get much better execution plan instead of just one row. So what about writing store procedures? When we write store procedures, normally our store procedures can be very simple. We just have a parameter, and we have some work, and we return some data. But what happens when we want to get a whole list of parameters? Well, we concatenate strings and in the front end, and then we want to split those strings in the back end. Well, that puts extra load on the SQL Server. And unless you're using SQL Server 26 string, you don't have a string split built-in function for it. So you're either going to write a CLR or do something else to split those strings. Well, what's the alternative? Well, alternative is using table variables. So how do you create a table variables? Well, very easy. You create a type, give it a name as table, define your columns, and you can even specify it as a primary key. So in my case, I just wanted to demonstrate just passing a single column to a single column to a store procedure. So how does it actually look on the front end? I know not many of you might be .NET developers, but when working with the .NET code and calling SQL store procedures to pass a table, it's called SQL data type structured, and you're just passing a whole object to it. So now, instead of somebody who's a front-end developer having to do extra work of taking that data table that they had and converting it to comma-separated string for you, they just take that whole IEnumerable structure and they pass it to you. So how does it look on the back end? So once we pass the whole data table to store procedure, since it acts almost identical to a table variable, we just join to it. So now I don't have to split my strings, worry about anything else. I'm just joining to it. And now I can make my store procedure smarter. And if I add option recompile or do something else to actually enable statistics into it, because just like the problem exists with table variables, there's probably not going to be any statistics with it. So let's look what happens when you actually call it. And let's clear the cache, make sure my flag is turned off. Execute the store procedure, but only pass a single item to it. And now we have to find where it's being selected. And estimated rows 1. So we passed one item and we're getting 1 row. So, well, I think we're in a good scenario. Well, what happens if we're trying to pass 100 items? So let's execute it. We're writing 100 items to a list and passing that whole list to store procedure. We're only getting 17 items back, but what happens in execution plan? We're still getting the same number of rows. We're still only getting 1 row. So I thought, well, I guess a table of variables always estimate 1 row. Well, it's apparently not. So let's free procache. Run our 100 rows. And go back. Go back. Find it. Estimated number of rows. Still 1. All right. Now we execute this again. And this doesn't work all the time, but what actually happens with SQL Server when it's using table variables, it will store the number of rows during the first execution. So if your first execution was with a single row, you will get 1 row estimated for every subsequent execution. But then the trace flag that we talked about earlier that affects table variables, it also affects table valid parameters. And in this case, we're still getting 1 row. So something must be still cached. Let's try this again. And we're still getting 1 row. All right. I must be doing something wrong in here. That's what happens when you're trying to work with something that doesn't generate exactly the same result every time.
Well.
But so this trace flag will affect table value parameters, but so be careful when working with it. Make sure that it's exactly what you need and it's not going to produce additional problems for you. So cursors. Why is cursor such a big problem in SQL Server? And I'm not going to mention him because he might actually be listening to, but this guy, who shall be left unnamed, wrote this amazing blog post on the different options that you can include on cursors and what they do. See, when coming from Oracle, I knew that the Oracle implementation of cursor was very fast. I didn't understand why implementation in SQL Server was so bad. So then I learned that when SQL Server was implementing cursors, they created the cursor that can do absolutely everything. Cursor can go backwards, cursor can go forward, can traverse, can skip forward, can skip back. Well, most of the time when we're running a cursor, all we need is a cursor that goes 1 row at a time, and it's only going forward. So the way we can define it, our cursor to do that is by using these 2 options, local and fast forward. So read the blog post. I included the link in the slides. It will explain in the more details than we really have the time for. But fast forward will force the cursor to only be a cursor that can be traversed forward 1 row at a time, instead of doing all this other stuff that we don't really need the cursor to do. And as you will find from a blog post, that it reduces memory usage, reduces the duration, even reduces pages in TempDB. And all we did was define extra options with cursor. So if you do have to use a cursor, at least now you know that there's options you can include with it to make it go faster. We're doing good on time. Error handling. When it comes to error handling, it was the second nature to me as a .NET developer. I learned try catch blocks pretty much right off the bat. So working with SQL Server, I forgot when the try catch blocks were introduced, but I were glad that they were. So the way I see it, it is a last option for us developers to make the code fail gracefully. A lot of times we don't want the code to fail and just commit some changes to be committed halfway through it. For example, if we're trying to delete some data or trying to insert it, we want everything to be executed, not just the beginning of it. And then if it fails halfway through it, we want to be able to roll back. Well, the easiest way, encapsulate it in a transaction with the try catch block. We can catch that error and roll it back. So when printing, what we do with that error, well, that's up to each developer. Sometimes you would just want to print that error message to the screen because you don't really want anybody else to know that your store procedure failed. But when you go to execute it, you'll be able to see that error message. Well, what about if you want that error message to be actual error message? Well, you can rethrow it by either catching all the appropriate information with it, and then using a raise roar, or simply in SQL Server 2012 and higher, you can just use a throw command, and if you use it from a catch block, it will act as a rethrow. So whatever exception was caught, it'll just throw it again. So let's look at the execution of it. So we execute a store procedure that caught an error, but nothing really happened. Well, because we print. So to see an actual message, we would have to go to the messages tab. So if this is something that's being called from a front end and they're not reading back the messages, they won't even know that that your store procedure failed. They just won't get the results back. When you execute a store procedure that actually throws an error, there will be additional information sent to the front end. Or even if you're running it from SSMS, it will change tabs for you, so you know right off the bat that there's the error and what it is. Plus you get this nice red text versus just the black text that you get from printing that error message. So I was talking about difference in throw versus raise roar. And with everybody does know that this is raise roar.
I've never heard it. That's great. I've never heard it called that before. No.
Oh, you must have never listened to videos from Tobias.
No.
Yeah, he's like, this is raise roar. I was like, what is he talking about? Then it's like, yeah, otherwise it would have been raise error.
Nice.
So what's the difference? Well, when we throw an error, we just have a very simple statement. We just print, throw an error, and select from table. Well, we don't get that select from table. Instead, we get the error message being thrown. So we would expect the same thing with the raise roar. Well, instead, we get the same error message, but we get some additional information, 16 rows affected. We go back to the results, and we actually find that the select was still executed. So even though you raised the error, you still got the select statement. Well, sometimes you don't want your code to continue going if you're raising an error based on some sort of user condition. You would want it to stop. Instead, in this case, we find that raise roar still goes on, and you still get that select statement, which in my case it's not bad. But what if it's a delete statement or something else that you don't want to do if the error was raised? So we think, well, then raise roar is bad and we're not going to use it. Well, actually not. We're going to use the same raise roar, same select from statement, but we're going to wrap it in the try catch block. All of a sudden, that select statement is no longer being executed because raise roar will act different when it's inside try catch block than it will outside of it. So if you have store procedure that doesn't have a try catch block and you have raise roar, the execution will continue. If you have a store procedure with the begin with the try catch block and you have raise roar, it will stop execution and you won't get that select statement, which is actually very similar scenario to what happens if we just have a generic error message. So here we're just doing some simple division by 0, which will give us an error, but execution still continues. So I'm not sure why Microsoft decided to do it, but with raising the error, you get the same behavior as you would if your code generated an error. But you wrap that same code in a try catch block, and then all of a sudden, when the error is thrown, it will catch it and execution will no longer continue. So just something to consider. There's differences when it comes to what SQL Server will do to it. All right, so let's talk about Visual Studio SQL Server data tools. Being a .NET developer, I lived in the Visual Studio. So when I found out that I can actually do my SQL Server development in Visual Studio, I was very excited because I could do all the things in Visual Studio that I learned and loved. So this is not an SSDT presentation. This is just a slight glimpse into what can be done with it. So here we have a table, store procedure, and one of the biggest difference between writing code in Visual Studio SSDT project versus writing in SSMS, if we already created the store procedure, we'll need to write it as an alter statement every subsequent time. When working on the code in Visual Studio, you always define it how it's going to be. So I never have to write an alter statement because it will actually complain. So it's always going to be a create store procedure, never an alter statement. Of course, with SQL Server 2016, you can use create if exist, I believe,
Drop
drop
if exist.
drop if exist. So there are some extra possibilities, but right off the bat, using Visual Studio, you write a declarative code. So you write the code how you want it to be, not how it is and how we're going to change it. So we have one simple table, one store procedure, and we have a table called Attendees with 3 columns: IDs, first name, and surname. I don't know why we called it surname, because maybe we're writing our application for it's gonna go worldwide and they don't always call it last name. So then we rolled out our application and everybody's happy until the manager comes along and says, well, we're not gonna roll out our application worldwide. It's gonna be only for America and we wanna call it last name. Well, so as a developer, you would come in and you would change it to a last name. And it's all great until you go back to store procedure. And now your store procedure doesn't work because, well, it expects a surname, but we changed our table to a last name. Well, now we're back to generating the code, trying to rename all the instances of that store procedures that we need to do. So there just has to be a better way of doing it. So with Visual Studio, there's some other capability that you have. One of it is this refactor menu. With the refactor, there's this little nifty thing called rename. So let's see what happens if we use a rename. So we'll give this a new column name. We save it. It says, well, I'm gonna change the column name, and we click apply. So it looked almost identical to what we did before. Instead, when we go to store procedure now, store procedure automatically changed because Visual Studio will keep track of dependencies of the objects, and when it notices that object changed, it will actually rename it for you. So just one little feature that, I mean, something that I wished you could do in SSMS, you can do it very easily in Visual Studio. So now instead of trying to find all the store procedures that you wrote and every instance when you use that column, you just bring the code into Visual Studio, change it using you refactor the code, and now all of a sudden you get that code changed for you. So one of the things that you will notice, there's a file called here refactor log. So what it does, it actually saves whenever columns were changed. So, and if anybody using your Redgate products, this is some of the things it can read, and when you're deploying it, it can generate different code. It will generate a code for you to alter a column name in the table, but it also knows that it needs to generate the code for store procedures to change it. Well, talking about Redgate, one of the features that we have from Redgate is schema compare. But for those of us that work for companies that don't want to buy Redgate tools because they don't feel like their developers are worth spending money on, we left to using the tools available to us. One of those is we get a schema compare as part of SSDT. And all you have to do is come to Tools, SQL Server, and do a new schema compare. Well, I already set it up, and I'm comparing my local project that I'm running in Visual Studio to the local instance database. And you get this nice little graphical interface of what happened. Oh, I have more tables than I have in my target than I have in my project. So we can drop them. We have a change, and we know exactly what the change was. So for those of us that don't have Redgate tools and schema compare, we can use tools that are available to us. So if somebody has Visual Studio as part of a products that they already use, this is some of the things they can do without trying to buy extra tools. Another thing I saw from Redgate is one of their new capabilities with, I believe, Ready Roll, which will probably make SSDT projects almost obsolete, but we'll see where it goes. We'll probably have to spend some time playing with it to see exactly what we can do with this.
Dana asks, do these features work only in the one database that you're in, or can they look across all the databases on a server to do this?
Well, so with the schema compare, you would have to select specific database to compare. So you can compare it between servers, you can compare databases, two databases on the same server, but it's whatever you have access to. So if you have access to that database, you can see it. Otherwise, you won't be able to compare it.
Okay.
All right, we talked about the tool called LinkPad. And let me start it up. And of course, it goes to the wrong screen. So one of the things that I love about this tiny little tool, it's very lightweight. I used to use it back when I was writing a lot of C# code, so I could write very small snippets of codes without having to start Visual Studio. I wanted to just write a small code, execute it, and just be done with it. Well, I realized that I can do the same thing with SQL statements. So over here, I have my Glenberry scripts that absolute necessity when it comes to troubleshooting performance. So with all the different scripts you have, for example, where's my SP-Who3? Once in a while, somebody calls you and says, hey, something's running on the server. We're not sure what's going on. So we come in here using the current, and we can just execute it. Yep. So it runs really fast, and the fact that this, I don't have to fire up SSMS, and sometimes SSMS can crash on me, or I have too many windows, or doing something else with it. This is just one of those tools I use to organize my scripts, and when I need something to run real quick, or to run, it's like, oh, well, I didn't want to run it against this database, I want to run it against different database. So it can be done very easily. And again, this tool is free. So just by using some free tools, you have more capabilities. This is not going to replace SSMS. And if you come in here, you won't be able to do any of the administrative things you expect SSMS to do, like creating schemas for you or doing anything else. This is just a lightweight tool that you can use for querying databases. And all right, back to Plan Explorer. One of the jobs I had earlier in my career was they gave me a SQL server that said, we want this database to be moved from 2008 R2 to 2012 and make sure to optimize every store procedure. They had over 200 store procedure. So now I'm working through every store procedure trying to performance tune it. So I don't know how I happened to go find Plan Explorer, but I fell in love with the fact that there's just, you can click on any individual statement, and you're looking at the plan diagram just for that statement. And if you have multiple screens, give me 1 second. You can actually use a whole real estate of that screen to see that plan. So with the small plan, it probably doesn't really matter, but when the plans are bigger, let me find a little bigger plan, it becomes much easier to see the bigger picture of it. And the bigger the screen that you have is just that much easier than trying to see that scroll bar in SSMS, scrolling back and forth, trying to find that one execution that we need. All right, 1 second. But I'll learn about another little thing right off the bat. When it comes to this cost in SSMS, that cost is estimated. So this is just what SQL Server thinks is going to cost you. So how do you find the most offensive query when you execute a store procedure and it has hundreds different statements and you have to go through and look through each one of the statements? Well, in here, I can sort by the duration that each statement took. And I have this wonderful statement that took 42 seconds, but the estimated cost was only 0.4%. So if I was going only based off estimated cost, I would never look at this query because you would just want to expect it to be taking most of your time. So then when it comes to actually figuring out what's wrong with the plan, well, this one is quite easy. We have index seek with the 274 million records coming back. So very quickly, just visually coming, I was able to identify a problem. Well, we have 275 million records. So I'll go look at the base table, and the base table only had about 700,000 records. So there was some poorly written code. But when looking at execution plans in Plan Explorer, let's say there's a plan that we don't really care what it's doing. We can just come in here and hide it. And then we're only looking at the part that we care about. We can filter by cost and do many other things that just you can't do right off the bat in SSMS. Another easy way of figuring out where your problem is by doing this cumulative, and then we can easily see which lag of the query we actually need to look at. And when the bigger the queries get, the more we can easily roll out to find the problems that we are looking for. So let's change it back to per node. Let's see, line width, or we can change it to data size. So with a single click, just making very, very simple changes. And now we're looking at total data coming back instead of number of rows. So once again, this tool is free from SentryOne. I'm not a spokesperson from SentryOne. I know a few people that work there, and they'll probably appreciate if you use their product. But when it comes to Plan Explorer, you can just go to their website, download it for free, no email address required, so they're not going to spam you with a whole bunch of emails asking you to buy the rest of their product. This is just something that they offer to a community. I believe Aaron Bertrand added a link to a Slack channel, which includes a full webinar on Plan Explorer. There's just so much more that that we can talk about when it comes to Plan Explorer that we just won't have the time. Like this whole index analysis tab, you can probably spend a whole hour just going over what they can show you on index analysis. But so this is just one of the tools you use, and it's something that can help you with development. And of course, when working with the big store procedures, a lot of times we go for this low-hanging fruit where we see most of our time being spent, and we can tune it pretty quick. But when the time is spread against multiple statements, that becomes a little harder because you have to tune each statement instead of just finding one statement that causing the most offense. All right, and that will be it. Let's go back to slides to make sure that we went over everything. And of course, I didn't click on the right slide. So tools. So everything, so the Visual Studio, there's a community edition that you can download completely for free. And this is one of the links that you can go through. There are some restrictions when it comes to using it in in your organization. So you can't just download it and use for your business, but you can use it for personally. And of course, SQL Server Developer Edition. One of the companies I worked for previously actually had gave me a MSDN license, so it was really easy for me to get all the things that I needed. Without having a MSDN license, it becomes a little more complicated when you're trying to run presentations and you need a SQL server. So what do? Well, you would just use to download either Express Edition or Evaluation. With SQL Server 2016 Developer Edition being free, now you can download it. You still have to jump through some hoops to get it, and there's multiple blog posts on multiple ways you can get Developer Edition downloaded for free. And time for Q&A. So I believe we actually ran a little quicker than estimated, probably because
You're doing good. You're doing good. It's always timing online ones is always trickier, and a lot of people ran early today too. Samuel says, "Does LinkPad have IntelliSense?"
yes. When it comes to LinkPad, there is option for IntelliSense, but unfortunately, it's a premium feature that you would have to buy. The cost is not that much, but it's just a little bit extra.
Gotcha. Teddy says, "Did you show that when you right-click on a query plan in Management Studio, it'll open in SQL Century Plan Explorer?" He loves that so much he didn't.
No, I didn't show it, and there's actually there's a reason why not to use it. So let me go back to temp tables. And no, I don't have the plugin on it. If you execute the plan in the SSMS and then you move it to Plan Explorer, some of the data will not be populated. So it's always better to execute the query out of the Plan Explorer, because then you get additional information that they capture while running it. Otherwise, you won't get it. One of the things that I also like about Plan Explorer, and you were talking about posting to your website, they offer you an option to anonymize your code. So then I'll take a second. And my computer's thinking. It should be one of those buttons that says "Do not press during
live presentation."
During live presentation. All right. So now that execution plan no longer has any of your proprietary information. So you will see use database 1, variable column names. So now you can still show the plan XML, and you can share that XML through brands or paste the plan without exposing any of your schema information. And also you won't be exposing the command you're running. People will still be able to read your command, but at least they won't be able to know what those objects are. So they might have. Yeah, go ahead.
If anyone ever sends me a query that looks like that to troubleshoot, I'm going to give you the finger, and it's not going to be the index finger. It's who wants to read that? That's heinous.
Well, but at least you can still see the joints, and if somebody has a cross joint here, you can just smack him and say, "Well, fix that cross joint before you send me the query." But at least it's
functions.
But at least it can be helpful to when you're sharing online and you don't want to give more information. Plus, they give you an option to Post to SQL Performance, which is one of the blogs, one of the places that Aaron Bertrand lives on. At one point, I thought Aaron Bertrand was a hive of people, but because every time I saw somebody posting a question on Stack Overflow, before the question was even posted, Aaron Bertrand already had a 5-paragraph answer on what was wrong with their SQL statement.
Yeah, he is really quick with that stuff. Well, thank you very much, sir, really appreciate you taking the time to present today. I want to thank everybody from the audience for hanging out with us today. Thanks for hanging out on Friday, April the 21st. Great presentation, Vladimir, and have a great weekend, everybody. We really appreciate you hanging out with us this weekend.
All right, thank you so much. And if you have any questions, send them to my email address. You can look me up on Twitter, LinkedIn, and can check out my blog. It doesn't have too many things, but once in a while I post something. It's more about trying to keep my own skills sharp and trying to remember stuff that I solve so I can find it in the future. So Thank you so much.